What is the best way to clean stormwater attenuation tanks? Now, there's a number of different methods to automatically clean storm tanks on the market. The tank size and the layout will dictate to some degree which methods are actually possible to deploy, but which method is best. Now, in our opinion, the hands down winner for almost all conceivable storm tanks is an automated rotary jet cleaning system, like our storm blaster system. Generally speaking, rotary jet cleaners will be cheaper to install, they'll give a more effective clean, you'll have to do less tank modifications to ensure that it works, and they'll clean a wider range of tank sizes and layouts. They'll do this more than any other method. So for almost all tank systems, rotary jet cleaners are the best choice. So the question is really not what is the best solution, the best way to clean a storm tank, but when is it appropriate not to use a jet cleaning system. So there's a couple of situations where it may not be possible to deploy these types of systems. So one situation is if we had a very, very large open tank, so a non-roofed tank. For example, if we had, say, a 60-meter long and 20-meter wide open tank, and it was not possible to add access walkways to position the tank cleaners centrally, then we'd be forced to position them on swing arms from the side. This could prove challenging in such a tank. It's not the length, it's the width that is the problem. We can deploy multiple tank cleaners down the length of the tank, but if we could only come in one side, that 20-meter width may be problematic because practical limitations of swing arms are about 2 to 3 meters, so we'd have like a 18 to 17 meter horizontal distance to cover to get to the other side of the tank. This could prove problematic even for the large storm blasters. Now, if we could come in from both sides, if we could hang them on both sides, then that wouldn't be a problem. You could just put storm blasters on each side of the tank and that would be fine. But if there was some reason why we couldn't get onto one side of the tank, then that could be a problem. A very large, open, very wide tank. Another situation where it may be problematic to use the storm blaster system is if there's almost no drain gradient in the tank. Now, obviously any purpose-built storm tank is going to have a suitable drain gradient because it's designed to be emptied, but some repurposed tanks may have gradients below 1%, and if it's much below a 1% gradient, then that can be problematic. If the liquid can't drain away quick enough, it will redeposit any sediment that gets blasted off by the storm blaster. Now, quite what you'd use as an alternative in these situations, I'm not quite sure, because all the other methods of automated tank cleaning also require a drain gradient, so there's going to be a problem there either way. Any gradient below about 1%, you're going to have a problem there. Another feasible situation is if for some reason you can't get a suitable booster pump or fluid pressure on site. Now, rotary jet cleaners need about 4 bar minimum of fluid pressure to operate, but ideally they'll work best between sort of 8 and 10 bar. If only sub 4 bar fluid pressure is available, then they're not really viable. This is especially true if the tanks are larger, as we need the higher pressure to get the necessary jet lengths there. In most situations, simple booster pump will solve this if you haven't got the pressure there on site already. But if that's not possible for whatever reason, then you may need to consider other methods of tank cleaning. These are the kind of limited situations where we would find it problematic to use a storm blaster system or a rotary jet cleaning system. But that being the case, they're quite limited. So why aren't they universally used? If they're the best method, why aren't they universally used? Well, this comes down to a few factors. Firstly, it's a lack of knowledge and understanding. Storm tank cleaning isn't a key application in the wastewater industries. It's kind of like a sideshow, if you like. It's not something you spend a huge amount of time thinking about. And so it can be quite difficult for newer ideas to permeate into the industry. The second reason that they're not universally adopted is there have been in the past some attempts to use this technology. A decade or so ago, there were attempts to use rotary jet cleaners from industry in storm tanks, and they didn't work very well. And the reason for that was that they were trying to use rotary jet cleaners that were used in nice, warm, cozy factories, and they put them outside in storm tanks, and they tended to break down. They tended to have reliability problems. Storm Blaster is different from that. We solved that with the Storm Blaster, and we solved that about 8 years ago since we've been deploying these systems. The main difference is that the Storm Blaster is based on technology not that was used in factories, but was used in the marine environment for cleaning oil tankers. So they're big, tougher, more robust machines that are used to dealing with poor quality wash water and to be sat outside exposed to the elements. They're originally in a marine environment, which is even harsher than sat outside in a storm tanker being exposed to the elements. That problem has been solved now, but there's still some legacy issues from those initial attempts using different rotary jet cleaners that didn't work particularly well. There's a misperception there. Thirdly, again, with those previous attempts, there's some incorrect cleaning protocols, and this resulted in a variety variety of missteps as well. Storm tanks are a different layout and different type of tank to factory tanks. Factory tanks tend to be sort of tall and thin, whereas storm tanks are sort of wide and fat. Now again, notice these storm tanks are actually quite similar profile to a oil tanker in many respects. So again, using the right technology and using the right protocols for designing these cleaning systems is important. And if you just take protocols and layouts that you use in a factory setting, in a say food tank or something like that, and apply them to a storm tank, which is a different kind of tank layout, they didn't work. So there were some problems there as well. We've developed the correct protocol now over the last 7 or 8 years, and we now have 130, 140 odd storm blasters out there working away with no problems at all, cleaning storm tanks very, very well. The fourth factor why they're not universally used is it's a relatively slow moving industry. We have quite sort of 7 or 8 years for spending cycles for infrastructure projects. New technology, especially in smaller applications like storm tank cleaning, aren't adopted very quickly. So it's just a question of time to get this technology out there. There's a kind of mentality around storm tank cleaning, oh, this is how we've always done it, so that's how we're always going to do it. And it takes a little time for us to get the message out there. A fifth reason why they're not universally adopted is necessity is the mother of invention. Storm tank cleaning hasn't been a particularly big problem so far. It is now, and it's becoming more of a problem. As we have more storm tanks near residential areas, it's becoming more and more of a problem, and environment agencies are starting to issue more and more fines for odour pollution caused by dirty storm tanks. That necessity is now being the mother of invention, and so we need better ways of cleaning storm tanks. As that continues, the best way of cleaning storm tanks, which is rotary jet cleaners, we think is going to be deployed more and more and more throughout the industry.